Hello everybody, welcome to the video going over the 10.1 to 10.2 practice, which is about graphing exponential functions and also graphing logarithmic functions. And right here, if you'd like, feel free to take a look at your 10.1 notes to help you with this, and your 10.2 notes to help you with this. These first two examples are written next to each other for a reason. I made them in a particular way that they are inverses of each other because both of them end up having the same base. So I'm going to be doing them at the same time here, which I hope will help you. First, here's the graph. First I ask, is this graph exponential or logarithmic? Well, if we're raising something to a power, this particular one is exponential. However, number 2, given this function, because you see a log in the problem, this one is logarithmic. The second question asks, what is the parent function of this graph? Well, if f of x is this, the shifting matters, the parent function represents the most basic graph without the shifting. So I'll call the parent function g of x this time, and the most basic version of this graph is just 4 to the x without the shifts. Number 2, the graph that I give you g of x involves some shifts, so the parent function, which I'll call f of x this time, is the most basic version of this log, which would be log base 4 of just x, no shift with 3 and no shift with the 5. Here's the real reason I put these two questions next to each other, so you can see the relationship over the last couple days' lessons. What are the two key points you need from the parent function to start graphing for the exponent? What are the two key points you need from the parent function of a log to start graphing? If you are graphing from an exponential, you might remember that if you plug in 0 for the exponent, you always get out 1. So one of the key points was 0, 1. And the other key point was when you plugged in 1 into the exponent, you always got out what the base was. So it was 1 comma a base. However, with today's lesson that you already watched, these 2 points ended up being flipped. When you plugged a 1 in, you got a 0 out. That's what we saw from the basic or parent log graph. And we saw base comma 1, which makes sense because you remember that the definition of an inverse from the video is that x equals y. So x equals y equals x, so your points can flip. So as long as you know these coordinates, you can do the rest of the problem. Where is the graph shifting? Well, both of these graphs, I purposely shifted them the same direction. If you see x minus 3, x is always opposite of what you think. So this graph is going right 3. This graph is going right 3. This graph is going down 5 because y always does what you want. This graph is also going down 5. The only difference is the parent function, and because the parent function, what the coordinates are where you start. What are the new key points now that you know what your shifts are? Well, if I started at 0, 1, and then I went right 3 down 5, right 3 affects the 0, and I'm adding on 3, down 5 affects the y, so 1 minus 5 is negative 4. Right 1, 1 plus 3 gives me 4. The base, in this case, if I'm going to be more if I rhymed, would give me the point 1 comma the base of 4. So this is the coordinate that I start with. So 1 plus 3 is 4. 4 minus 5 gives me negative 1. So these are my two new points I'm going to use to graph here. For the second example, base comma 1, the base is 4 comma 1, so that's the point I start with here. So if I shift this point right 3, that would be 4. If I shift this first point down 5, that would be negative 5 from 0. And then if I go right 3, that's 4 plus 3 or 7. Down 5, 1 minus 5 gives me negative 4. So these are the 2 points that I start with in this case. So if I were to graph the first function, I would graph the points 3, negative 4 and 4, negative 1. And then I have to remember what an exponential function looks like. Well, my exponential function either looks like growth or looks like decay, and your asymptote is horizontal. So here are my 2 points. My parent function, my asymptote is at y equals 0, so on that x-axis. So then if I am shifting down 5 units, my asymptote is now going to be at y equals negative 5. So I draw a dotted horizontal line there. I will go close to the horizontal asymptote, connect my 2 points, and rise quickly like an exponential function. So there is a sketch of graph 1. Graph 2, if I plot these 2 points, let me move this up a bit. 4, -5 is right here, and then 7, -4 here. For the parent function of a log, if the parent function of an exponential is horizontal asymptote, that means that the asymptote for a parent log function is a vertical asymptote. The vertical asymptote for the parent function starts at x = 0, but if we are shifting to the right 3 units, that means now that my vertical asymptote is at x = 3. So my graph would look something like this, close to the asymptote. Connect your points, and your graph goes forever there to the right. So if I took this log graph and I put it on top of this exponential graph, these two graphs would reflect over y = x because they're inverses of each other. Now that I have my two graphs, I can answer the following questions. The domain of this green function from left to right is negative to positive infinity. The range is from the bottommost value to the topmost value, so bottom to top. So the bottommost value is -5, not included. And then I go all the way up to infinity. The asymptote we already figured out is the line y = -5. And then you ask yourself, do you have any intercepts? Well, if I take a look at my graph, I do have an intercept, a y-intercept about there, and an x-intercept about there. So I'm going to write a note that we do have both x and y intercepts for this problem. However, for now, I only want to find the y-intercept, because in order to find the x-intercept, you need to solve using logs, and that is at a later unit in this chapter. So I'm going to come back to that with graphing when we get to solving those lovely log equations. So that is to come. If I'd like to find my y-intercept, though, that means that x is 0. So if I bring down my original function is 4 to the x minus 3 minus 5 equals y. Sorry about that. Equals y. That means I can plug in 0 for x. So I have y equals 4 to the 0 minus 3 power minus 5. And this answer is going to be odd, but it's good review. Y equals 4 to the -3rd power minus 5. You might recall from the first video that negative exponents do not lead to negative numbers, they lead to reciprocals. So 4 to the +3rd is 64, which means 4 to the -3rd is 1/64. So this is 1/64, which is a very small decimal, minus 5, which would be y equals 0.0156 minus 5, which is -4.994. So that means that my y-intercept is the coordinate, come on, it's okay technology, you can do it, 0, -4.984. And let's see if that looks reasonable to us. If we look back at our graph, yeah, that looks like it could be almost -5, but not quite. So this next example, if we want to find the domain of this log function, the domain is from left to right again. So if we look at the red function, it starts at 3 and then goes forever towards the right times towards infinity. 3 is not included because it's at an asymptote, so we'd have a parenthesis around 3. The range would be bottom to top. So the graph goes forever towards negative infinity and forever slowly towards positive infinity. So the range is negative infinity to positive infinity, which again makes sense with the idea of an inverse, because the domain of one would be the range of the other, because x's and y's flip. Your asymptote is the line you can't cross, which in this case we said was x = 3. And then in terms of intercepts this time, does this red graph cross the x-axis? Looks like it would cross the x-axis somewhere over here. But in order to find that, you need to use logs. So I'm going to write a note that yes, we have an x-intercept, but we will find at a later point in this unit. There is no y-intercept though, because it does not cross the y-axis. So no y-intercept, yes, an x. So it might be good just right now to identify that there's an x-intercept, but not necessarily find its coordinates yet. Okay, these. These are more like what you might see on an exit slip. Graph by hand, graph this function, consider the parent function first, and find the key points, then consider the shifts. After you've graphed, please find the domain range, asymptote, and intercepts. So first, let's ask ourselves what the parent function is. If we take a look at this picture, we have shifting, so we need the graph without shifting. So my parent function would be something like g of x or f of x equals 1/2 to the x power. So my key points when I have an exponential function would be 0, 1, and then 1 comma the base. So in this case, the key points are 0, 1, and 1 comma 1/2. If we deal with the shifting, what's happening is if we see x plus 5, that's the opposite of what you think. So this is really going to the left 5 units, and then this is also going down 4 units. So if I took the 2 points that I originally had for my parent function, if I'm going left 5, that means it's 0 minus 5 here, and 1 minus 5 here. And if I'm going down 4, this would become negative 3, and 1/2 minus 4 is negative 3.5. So these are the 2 points that you would plot over here. Negative 5, negative 3, boom, negative 4, negative 3.5, bam. And then you would think about your asymptote. So with an exponential function, your parent function, your horizontal asymptote is at y equals 0, so it's here. However, the graph is going down 4 units. So that means that the horizontal asymptote would move down 4, and then my graph would look like this. The reason that it's going the opposite direction as the one that we did earlier is because this time the base is 1/2. So this means this exponential decay, so it's decaying from left to right, not rising from left to right. Now that I have my picture, I can answer my domain questions and beyond. So domain from left to right is going to be negative to positive infinity, because we have the graph going forever this way and forever this way. The range would be bottom to top, so the lowest value that we have is negative 4 not included, and the graph skyrockets to positive infinity. And don't be dismayed by the fact that the graph is going the opposite direction. If you're still thinking bottom to top, even though this is decreasing from left to right, it is still increasing up to infinity. The asymptote we said was now the line y equals negative 4. And lastly, are there any intercepts? Well, yes, I'm going to say yes, there are both x and y. However, the only one we are going to find in this video so far is the y-intercept, because again, this one involves logs. We'll do that later. So I was going to find the y-intercept, though I am going to plug in x equals 0 into my original equation. So that would be 1/2 to the 0 plus 5 minus 4, which would really be 1/2 to the 5th minus 4, which, if I'm raising a fraction to the 5th power, that really means the top to the 5th and the bottom to the 5th minus 4. So 1 to the 5th is 1, 2 to the 5th is 32, subtracted 4. If in the calculator, for understanding it on a graph purposes, I change this to a decimal and do 1/32 minus 4, that would be negative 3.969, which, again, makes sense right here. It looks like it's almost a negative 4, but not quite. So the equation, or the point would be 0, negative 3.969. You could also get a common denominator here and leave your answer as a fraction, but just because we're graphing, I think that decimals might make more sense in this case. The next example, graph by hand. This time you're given a log function. Again, please consider your parent function first and your key points, and then do the shifting. So this time, now that we're dealing with a log function, the parent function would be g of x, you could say f or g of x, equals just log base 2 of x only, no shifts. So the key points of any parent function for logs is going to be 1, 0, because it's the inverse or the flipping of the exponential, and then base, 1, which in this case is going to be 2, 1. So these are the 2 points that are correct for my parent function. If I think about the shifting this time, if we see x plus 4, that really means we're going left 4. And if I see plus 1, that really means we're going up 1 unit. So if I apply those changes to my points, left 4, 1 minus 4 is negative 3. And then 2 minus 4 is negative 2. My up 1 was 0 plus 1 affects my y value there, and then 1 plus 1 gives me 2. So these are the two coordinates here that I'm going to plot on my graph, negative 3, comma 1, and negative 2, comma 2, which would be here. If we're thinking about what my graph is going to look like, the parent function of a log, again, has a asymptote at x equals 0, but this time we are shifting to the left 4 units. So that means that my vertical asymptote goes from my y-axis over to x equals 4. So that means that my graph would look like this. It's close to the asymptote, connect my two dots, and it goes forever this direction. Now, before we go to the other information, I'd like to point out to you that when you see these two dots here, it's really tempting to connect them and make it look exponential like this. But what you need to remember when you are graphing this, because you're only given 2 points, is if you are given a log functions generally look more like this with a vertical asymptote. So when you're graphing a log, please consider that your function looks like that and not exponential at this stage. Now that we have our blue graph, my domain is going to be negative 4 to infinity, because my graph exists only from negative 4 to the right. My range exists all the way down to negative infinity and all the way up to positive infinity, because it's going to keep creeping. So my range is negative infinity to positive infinity. The asymptote we said is the vertical line, x equals negative 4. And if we think about intercepts, this one said x-intercept, but I just want you to have right? I think your version just says intercepts. Let's think about first if this graph has both. If we take a look at the blue function, it crosses the x-axis and the y-axis. It looks like it crosses at negative 3, but my graph is just a sketch, so I'm not 100% sure. So I'm going to write a note that we have both x and y intercepts. However, the original function is a log, and again, we haven't worked with yet this year about converting a log to an exponent to a log, or solving equations. So I'm going to make a note that yes, we do have both intercepts, but we're going to find both at a later point. So I'll probably try to come back to a problem similar to this in later videos or later practice problems. In fact, the part 2 to this particular section we're on is going to help. And so the next time we have class, hopefully we can be able to solve something like this or be able to answer the questions either here or later on. So anyway, stick tight on that. Last question we want to do, one more graphing log. This time I purposely put a negative in front to remind you again what that does, and just to do a little bit of review here. So we're dealing with a log function again, so my parent function again is going to be a basic log without the shifts. This time my base is 5. The negative also means a shift, so we're not going to put that in my parent function. My parent function is just log base 5 of x. My key points here are going to be, because if we have a log function, it's going to be 1, 0 as one key point, and the other one is the base, 0, which the base of this log is the 5, so it'll be 5, 1. Those are my 2 points to start. The graph is shifting, so x minus 2 means we're going to the right 2 units, and we're going up 3 units. So, also though, before we do the shifts, we need to consider this negative as well. The negative, you might remember from second semester that the negative is multiplying the function. And so if you're doing the order of operations, you need to worry about the negative first. And this negative is really multiplying all your y values. So what you're really doing is reflecting over the x-axis, because if you think about it, if you have a y value up here and the y becomes negative, it comes down here, so you are flipping over the x-axis. So we need to consider the reflection first before we do the right and up, because order of operations says multiplication comes before addition and subtraction. So if I take a look at the point 1, 0, I'm going to put this in order this time. If I take 1, 0 and I worry about the negative first, all my y values are being multiplied by a negative. This time, the y value happens to be 0, so negative times 0 is just 0. So my point starts off at 1, 0. Then, if I go right 2, I'm going to change my point to be 3, 0. And then finally, if I move up 3, my point's going to end up being 3, 3. So I plot that point right here. The second coordinate, 5, 1, if I deal with the negative first and multiply all my y values by a negative, my coordinate becomes 5, -1. And then I move right 2. So that means it would become 7, -1. And then if I go up 3, it affects the -1. So that would be 7, 2. So this is my second point that I plot. Okay. So now let's think about the asymptote. The asymptote originally for the log function is always a vertical asymptote at x equals 0. However, we shifted 2 to the right. So that means that my graph, my asymptote is going to be x equals 2 instead. And my graph is going to this time be flipped because we reflected over the x-axis. So if you take a look back at number 4, this log graph looked like this. And if you think about if it flips over the x-axis, this part's going to come down and this part's going to come up, which looks like this piece. So it makes sense with our previous examples as well. Now that I have my graph, my domain is going to be from left to right. This function starts at 2 and goes to infinity. The range is going to be bottom to top. This piece of your graph is going to go down forever, and this piece of the graph is going to go up forever. So my range is still negative to positive infinity. Didn't matter if it reflected over the x-axis there. The asymptote we found was x equals positive 2. And lastly, let's think about the intercepts. Again, I asked just for x here, but your sheet should just say intercepts. This time there is not a y-intercept because it does not cross the y-axis. There is an x-intercept. If this graph keeps creeping and creeping down, it'll be somewhere over here, probably somewhere between 10 and 12. However, we again will find this later, the actual value at a later point. Just want you to, at this point, to identify that there is an x-intercept. Okay? All right, guys, I hope this video was helpful. Feel free to go back and watch any pieces that you need, and feel free to move on to the exit slip. Thank you.